talk about some common mistakes. So the first one, the solution was no solution. The parallel lines, they don't cross. You didn't really need an explanation or work for that one. If you provided one or work, that was fine, but you didn't need it. Questions on that first one? Infinitely many solutions is when the two lines overlap, so it's the same line, but they're on top of one another. For number 2, you have to solve both of these, put them back in slope-intercept form. So subtract 2x and 6x. You have negative y equals negative 2x minus 3, and 2y equals negative 6x minus 4. For this one, divide everything by negative 1. And this would become 2x plus 3. The other one, divide everything by 2. So that this one would become y equals negative 3x minus 2. And then graph both ones. So for this one, start at positive 3. Go up 2 to the right one as many times as possible. And down to the left one as many times as possible. And then for the other one, start at negative 2 and go up 3 to the left one. As many times as possible. And down 3 to the right one as many times as possible. And then find where those two lines cross, which would be at negative 1. So the 5 points on that were, did you get the two equations correctly? Solved and the correct answers. And then did you graph the two equations correctly? And then the final answer. Some of us, not many, but forgot our negative, and that changed the whole equation, or didn't simplify, and we should be simplifying everything at this point. Questions on that? On to the next. There were different ways to do the substitution and the elimination. Your way may be different than what I'm about to do. Do not change it, don't erase. For substitution, you could have used either of these two, or in this case, either of these two, because you would have gotten whole numbers for everything. That's not always just in this problem. I know in some other classes a lot of us solved here. I don't remember what was in the words here, so I'm just going to solve for y in this equation. Again, if this is not what you did, that's okay. If you still want to write this method down, you can. It did not matter when you solved this if it was in slope-intercept form or not. You just had to substitute it back into the other equation. This didn't happen often, but there were a couple, I don't remember in this class or other classes, that put it back into the wrong equation. So we solved one of them and then we put it back into the same equation, which canceled everything out. So be careful, don't do that. Put it into the other one, not the same one. And then distribute. Some of us, when we distributed here, got a negative here instead of a plus, and then the variables canceled out, and some of you got no solution. We shouldn't have gotten no solution, so be careful there. We should have been able to combine like terms. And then add 24 to both sides, and divide both by 4. So your x was, you could have wrote two different things, 5/2 or 2.5, either or, because it was a nice decimal. You did get decimals for this. So on the test, if you get decimals, at the end you have your calculator for this section, you could put them back in for this and see do they equal this. If they do, you know that's right. If they don't, something's off, go back and fix your work, your answer. And then after you find your x, you could put that back into, this would probably be the easiest. Y equals 12 minus 2.5, so that y equals 9.5, or 19/2. So the 5 points on that were, did you set up your substitution correctly, however you did that? Did you solve for x correctly, get the correct x value, solve for y correctly, and get the correct y value? Do we have any questions on that? For your elimination, you should have gotten the same answer for these because it was the same problem. If you got two different answers for the same problem, you should have double-checked your work. Again, there were different ways to eliminate this. Most of us just multiplied the second one by 2. Remember that you were multiplying everything by 2, the x, the y, and the 12, not just the x and the y. Some of us did multiply the first one by 2 and the second one by 4. It didn't matter, though. Some of us, when we brought, I think, this one down, we changed it to a minus instead of a plus. Maybe we're looking at this one, I'm not sure. So be careful that you're not doing that, because that is also how you would have gotten no solution. So here, if I were eliminating the x's, I could subtract. These would become 0. -2 minus 2 would be -4y. -14 minus 12 would be negative. Sorry, I didn't multiply as well. Do very well. -14 minus 24 would be -38. So that y would be 9.5. And then you can put that back into any of these equations. To find x, I'm going to use this one. So x plus 9.5 equals 12, and get rid of 9.5. I don't think this really happened in this class, but after you find one variable, you don't have to do the whole substitution or the whole elimination method again to find the other. Just put it back in one of the equations. So the 5 points again, we're setting up your elimination correctly, or however you did that. Solving for y or x, whichever one you did first, correctly getting that correct value, and then the other variable and that correct value. For a total of 10 points. Do you have any questions on the elimination part? The word problem, I feel like most of us did fine there. It was really this that gave us difficulty. But there were some issues with the word problems. So, I highlight the important pieces of it. I'm not going to read it. Some of the bolded information was your important information. The 15 student tickets, the 16 student tickets, the 10 adult tickets, the 14 adult tickets, and then you have your totals, 300 and 375. And then the question asked, what is the price of one adult ticket and one student ticket? So when you were defining your variables, you should have said something about price of, cost of, adult ticket price, something with that word in it. If you use number of, you need to double check question or the answers. So I'm going to use A and S. You could have used whatever variables you wanted. You didn't have to write it exactly like this to get price. But as long as you had price in there or cost of or price of somewhere in there, that was fine. You didn't, you lost points there. And then your two equations, you had 6 numbers, so you should have used all 6 numbers. So 15s plus 10a equals 300. And 16s plus 14a equals 375. Then there were different ways to solve it. I would say if you have 6 numbers like this where you don't have a variable by itself, use elimination. If you use substitution, which some of you did, you're going to get fractions, but depending on what you solve for, you may not get nice fractions. So here, if we had solved for substitution by substitution and solved for this A, when dividing, we have nice enough decimals fractions. I want to say 16 had decimals, but they were decimals that stopped, not repeating, so you could have used that. But the other 2 had repeating decimals, and those would not have been good numbers to solve for or use. If we solve for elimination, there were different ways to do that. I'm going to write this down first. If you're not sure what to multiply them by, you can always just multiply them by each other. So 15 and 16 was a good option. 10 and 14 was a good option. Some of you that did elimination found one more. I think it was 5 and 7. So if we multiply this by 7 and this by 5, we would get 105s plus 70a equals 2100. And 80s plus 70a equals 1875. Then to eliminate the a's, we could have subtracted. So we have 25s plus 0 equals 225. And divide both sides by 25. So that s equals 9. And that was $9. So you should have had some unit, even if it says price of already, you should have some unit there. And then you can put that 9 back in one of the equations. It does not matter which one. Many of us, if we did this, use this one. 15 times 9 plus 10a equals 300. We have 135 plus 10a equals 300. Subtract 135. 10a equals 165, and divide both sides by 10. So that a equals 16.5. $16.50. You have to make those up. So someone, I don't remember who did this in this class, someone figured out if I were to multiply 10 by 7, I get 70. Could 14 also go into 70, and then figured out what number would multiply, and then came up with these. So you have to guess. You don't know that off the top of your head, just use the numbers given. So the points there were your 2 points for your defining, your 2 points for your equations. However you set up to solve, whether that was substitution or elimination. solving for one of the variables correctly, solving for the other variable correctly, and then your two answers to get a total of 9 points. Other questions there? Do you have any questions in general about anything? Yes.
What do you do if you don't get good fractions for the substitution?
If you don't do good fractions, you need decimals. If you don't get good decimals, like they're repeating decimals, leave them as fractions. Also, with substitution, remember that you don't have to solve for y, solve for whatever variable is by itself. If none, and you have a choice, use elimination. If none and you don't have a choice, you'll have fractions, decimals. Other questions? Go ahead and clear up your desk. Put your calculator up. You're going to start with the no calculator section. Put your calculator behind your phone.